Okay, let's do another example with arcs of current. So let's say that we have current going straight in this way, and it arcs over this way, and then straight out, and then arcs back that way. Okay, so the current is doing this. So there's my current. Okay, and let's say that these arcs here like that. So let's say this is R1 and then that one is R2. So let me give you parameters here. Okay, so let's say the current is going to be 6.31 amps. Let's say that R1 is going to be 1.5 centimeters. R2 is going to be equal to 2.88 centimeters. And the other thing you need to know is what is this angle right here. So let's say the angle is going to be 150 degrees. Okay, and so I want to know what is the magnetic field at the point there, at the center of curvature of those arcs. Well, once again, we know the magnetic field of an arc is going to be equal to mu naught I phi over 4 pi times r squared. Okay. So times r, rather. Okay. So what we want to do is say, okay, the mu naught, the I, we got the r's given to us. What about that? Okay. We know the angle has to be in radians. That must be in radians. But I gave it to you in degrees. So that means, phi equals 150 degrees, and well, then radians. So we know that that's 150 degrees, and we know that that pi radians is the same as 180 degrees. And so that means that we multiply that out. This comes out to be 2.62 radians. Okay. Once again, you must have that in radians. Okay. So the other thing we need to keep track of is direction. So we have this arc and we have the other arc. So if current is going that way, current's going this way. So what you can do, right-hand rule, okay, we find several ways of using the right-hand rule. You put your thumb in the direction of the current, your fingers curl around. The other thing is you can just, curl your hand so your fingers are curling in the direction of the loop, and your thumb points towards the magnetic field. Either way, this one, the inner one, is going to be into the screen, and the outer one is going to be out of the screen. So that one is going to be negative, and that one's going to be positive if we assume that out is positive and in is negative. All right, so now that means the magnetic field is mu naught I phi over 4 pi R2 minus mu naught I phi over 4 pi R1. Okay, giving our plus and minus together. We can make that neater, say mu naught I phi over 4 pi 1 over R2 minus 1 over R1. Okay. Plug in the numbers that you were given there, and that comes out to be minus 5.28 times 10 to the minus 5th Tesla, and that is in, like that. Okay. If you wanted to, you could also write that as minus 0.528 Gauss. Okay, if you prefer using Gauss instead of Tesla for such small magnetic fields. Either way is acceptable. So, again, this is not that difficult of a problem. You just have to keep track of things. You must make sure that phi is in radians, otherwise it does not work. And then you have to keep track of directions using the right-hand rule. Otherwise, it didn't work. So those two things are the key to actually solving these arc problems. And other than that, they're actually pretty straightforward.